Let's prove this particular theorem. So I'll give you guys the diagram and I'll give you guys the hint. You guys have to think. So let's take up minor arc itself, and this is true for all the arcs. So it's okay. You guys need not draw all the diagrams. Just one is good enough. So we have the minor arc subtending angle at the center in this manner, and something like this with the remaining part. So this is O. Say that's P. So we have triangle, or we have A, B as your arc, and the angle subtended by this is AOB and APB with the center and with the circumference respectively. So now, okay, let me actually write everything and then give you guys the clue. Consider a circle with center O. Let us consider an arc APB, APB, capital actually, subtending angle AOB at the center, and okay, this I have to change that, and angle AMB with remaining part of the circle. So what is that we need to prove? To prove angle AMB, or 2 times of angle AM, actually let me do this, angle AOB is 2 times that of angle AMB. This is what we need to prove. Now how do we prove this? So the clue is construction, right? So draw a line segment passing MO. So basically extend, join MO and extend it, say to point Q, or say N. So join MO and extend it to point N. Okay, so that's your construction, right? So that's your clue. One more clue I'll give you guys. Exterior angle property. So that's your another clue. Okay, let's think about the proof. Consider triangle AOM. So let's look into triangle AOM. So we have something like this. So this is AOM and that's N. So now these two lengths are equal. AO is equal to OM. Why is it so? AO is equal to OM. Why? Because they are, yes, radius, right? Both are radiuses, so they are equal. With this, what can I tell? With this, I can tell that angle OAM is equal to angle OMA. These two angles are equal. Why? Angles opposite to equal sides in a triangle are equal. That's the reason. I should change the color actually. Are equal. So what else? Let's call this as some angle XOAM, which is equal to OMA. Let's call this as X. Okay, what is the point of doing all this? See, the thing is, we are trying to establish a relationship between AOB and AMB. So AON is part of this, whole thing. And this is equal to, as you can see, it will be equal to 2x. But why is it so? Therefore, angle AON will be equal to 2x. Why is it so? Exterior angle of a triangle, because of that. Right? So exterior angle is equal to sum of interior opposite angles. So we have AON is sum of OAM and AMO. Right? So exterior angles of a triangle is, we'll write the entire thing just for the case of clarity, of a triangle is equal to sum of interior opposite angles. Right? So with this we can tell that it's equal to 2x. So that's good. Now what else? Now consider triangle MOB. So it's a similar case. We'll call this as, say, Y. Let me use some other color. This is Y and this is Y. So this will be 2Y. Right? So we need not draw another diagram again. And this also you need not draw in exam. It's only for understanding. So angle OMB is equal to angle OBM, as MO is equal to OB. They are radii. Right? That's all. You need not write more that angles opposite to equal sides of a triangle are equal. Not required. Then you just write let angle OMB, which is equal to angle OBM, which is equal to Y. Again, it can't be X. You can clearly see actually these two triangles are, can I tell it's congruent? Need not be actually. Here it looks congruent, but it need not be. So yes, so these two angles will be different. So we'll call this as Y, and we'll tell therefore angle NOB is equal to 2Y. So exterior angle of triangle, and with this we can conclude at last. So we'll call this as 1, we'll call this as 2. So if we add 1 and 2, 1 plus 2, what will we get? We will get that angle AON plus angle NOB is equal to 2x plus 2y. So these two angles are nothing but angle AOB is equal to 2 times of x plus 2y. And then we need to add from B and A. Okay. So from B and A, what do we get? From A and B, or from A plus B. So A plus B deals with angle AMO and MOB. So which is X and Y. So that's X and that's Y. angle AMO plus angle MOB, which is equal to x plus y. Actually, this could have been 2 times of x plus y. A bit of simplification will help. Now, this is nothing but angle MOB. Sorry, AMB. It's supposed to be AMB. So that's x plus y. Now we'll call this as first and second. So from first and second, what can we tell? From first, second and first. Okay, just go with the flow, don't think too much. Like I wrote second first and then first later. So don't think too much about all this. You can name anyhow you guys want. Not at all an issue. So what can we tell? Angle AOB, which is equal to 2 times of x plus y. This will be equal to 2 times of angle AMB, hence proved. Right? So this is at the center and that's at the circumference. And we have proved it. So this is 2x, 2y, x and y. So this is your proof.